Okay, guys, we're going to start this week similar fashion. I took all of your advice and trying to implement it as best as I can with these code references. There's just so much to cover so quickly to do it that we're going to kind of breeze through some of this stuff. I made this section smaller. I don't know how much it's going to help, but we'll see. Lesson 420. Lesson 420. That's where we're at. Cable types and flexible cords, general installation requirements. As I'm trying to make sure this is sliding. Okay, so the objectives of this lesson 420 are to review, and I want to reiterate the fact that this is review. This is stuff you guys should have already covered pretty extensively. If not, it's okay. We can get you up to speed, but it's important for you to do that legwork. 420.1, review NEC requirements for the general installation of any cable. 420.2, review NEC requirements for the use of specific cable and flexible cord wiring methods. And 420.3, review NEC requirements for underground installations. So as we move through this, you're going to see where I started kind of dropping it down. We're going to kind of tackle the first objective, the 420.1. We're going to cover cable installation requirements. Now, one thing I'm starting to figure out in the way these slides are set up, that it kind of gives you the highlights to jog your memory, but things that may pop up during the code test. So here's what's funny. 300.1, the scope. The article does not apply to the internal parts of equipment like motors, controllers, or utilization equipment. So when we're talking about this wiring methods and materials, it is not applicable to something that is pre-built, something that comes pre-wired, pre-built. It's only talking about the wiring methods between the 2 points. 300.3, single conductors must be installed in a Chapter 3 wiring method. You cannot just free air single conductors. They need to be in some sort of protection, Chapter 3 wiring method, some sort of raceway system. Continues to say all conductors of a circuit and any equipment grounding conductor must be in the same raceway, cable tray, trench, cord, etc., unless allowed in 300.3b1 through b4. So the violation is they separated it to make it easier to pull. You have to have the circuit together. Okay. So B1, any connection to the conductors must be made to each conductor in the parallel set. Okay. So tapping only one set of these conductors would violate this requirement. Example, isolated phase and neutral conductors may be in underground non-metallic raceways if the raceways are in close proximity and 300.20b is satisfied. I said example, I meant exception. Okay, for parallel conductors. 300.3b2, grounding and bonding conductors. Equipment grounding conductors may be installed by themselves in existing installations 250-130C or where installed on the outside of raceways for up to 6 foot in length. Mainly serves the purpose of bonding. It's kind of a bond around method. 300.3, conductors in the same raceway. All conductors in a circuit and any equipment grounding conductor must be in the same raceway, cable tray. We've already reiterated that. It's another example right there. Can't figure out why they would have separated the neutrals there, but they felt like it was necessary. Okay. So C1, 1,000 volts or less. Informational note 1, 725.136a prohibits class 2 and class 3 circuits in the same enclosure as conductors for lighting and power unless allowed in 725.136b through I. Violation on the left, compliant on the right. The compliance is it separates. There's a barrier that separates it. Another informational note is PV circuits, photovoltaic circuits, must not be in an enclosure, cable, raceway, etc., with conductors that are not associated with the PV circuit conductors. Some additions to 690. Continuing on, conductors of different voltages may be in the same enclosure, raceway, cable, etc., if their insulation rating is not less than the voltage in the enclosure, raceway, etc. 12208, 277 volt wire in wireway is allowed if all the conductors are rated at least 480 volts, typically 600. We know that. So now protection against physical damage. Very important to remember that we have to protect the conductors from physical damage even inside the wall. So plates are not required to protect RMC, IMC, PVC, or EMT. I can't quite figure out the PVC one because a drywaller could still send a screw through the PVC, but I do know that the other three definitely will stop that situation unless the drywaller is really pushing hard on the screws. So holes for wiring in wood members must be 1¼ inches from the face of the stud, rafter, etc., or the hole must be covered with a steel plate at least 1/16 of an inch thick. I would say that that applies to mainly residential guys, but actually commercial under, I think it's 4 stories. You have to protect those things unless they were in the aforementioned raceways on the previous slide. Continuing with the protection, plates are not required. They're reiterating it again to protect those 4 items. Notches in the wood, wiring installed in a notch wood member must be protected. Okay. Non-metallic sheath cable, NM cable. If NM cable passes through slots or holes in metal members, listed grommets or bushings installed prior to the cable installation are required. Okay, 300.4B1. 300.4B2 with NM cable or ENT, sometimes referred to as Smurf tube. Nail plates thinner than 1/16 of an inch are allowed if they're listed and marked. Okay, so that means they need to be listed by some testing and marked as such. B2 still under NM cable or ENT. If nails or screws are likely to penetrate NM cable or electric non-metallic tubing, a plate or similar must be installed. Just other examples moving through it kind of show you. Moving on to 300.4D, wiring parallel to framing members and furring strips. Where screws or nails are likely to penetrate, wiring must be 1¼ inches from the edge of the framing member or furring strip where installed parallel to them. So they're showing in that particular instance there, if they drywall that ceiling, which looks like that's what they're going to do, that they're going to be shooting the drywall, it looks like, to those 2x on the left and right. And so you need to be at least 1.25 inches away from that running your cabling. Same thing, listed and marked. Where screws and nails are likely to penetrate, they're just showing you another example of making sure you're back far enough to protect. So E, wiring and boxes in or under roof decking. Okay, informational note, this ensures that screws used for roofing materials do not damage wiring systems during the initial installation or when the roof is replaced. Still got to keep that distance there. You can't run up in that pocket, which would make sense. You got to be at least 1.5 inches. Okay, 1.5 inches from the decking. So the violation on the left, you guys can see why. Because it's one of those cables or cable assembly. The right is not a violation because it is one of those. Nope, let me back up. I'm on pause. It is a violation because in this situation, when it comes to roof decking, cables, raceways, and boxes, so they don't have an exception for the type of raceway it is. Sorry, my brain floated off there for a minute. Fittings. Fittings made of insulating material can be used for this requirement, but they are not allowed for mechanically securing the raceway to the enclosure. You still have to have that lock. That's the imperative part, that you have to, it's protecting your cables, but you still have to have that lock. A listed metal fitting with smooth round edges can be used. So raceways with circuit conductors 4 or larger must have one of the following to protect the insulation. You see the violation there. You have to so now remember, we're still trying to protect against physical damage, so structural joints, expansion, deflection, expansion fittings, deflection fittings. Some other approved method must be installed where raceways cross over structural joints for expansion, contraction, and deflection. You know, most building sizes, this is not an issue. If you get into really large warehouses, this becomes an actual issue. There's a couple methods there. They actually make a fitting that would go between those two boxes. That's a straight piece of raceway and it slides in and out of itself. And then they accomplished it by using seal tight, flex, something like that. So H, a listed expansion. Here's another one. They're just showing you the ones I was just talking about. Expansion fitting between where that goes. Where subject to physical damage, conductors, raceways, and cables must be protected. They just keep reiterating it. So it's kind of a reminder, roof decks, 1.5 inches from a stud, 1.25 inches. There are 4 raceways that you don't need the deflection plates, and that is IMC, GRC, PVC, EMT. Take a break for questions. We'll go from there.